The 11th of February 1942, the grey winter sea in the English Channel is chopped into whitecaps, and below a low cloud-based 3 German capital ships, Scharnhorst, Gneisenau, and Prince Eugen, are doing something that on paper should be suicidal, steaming straight through Britain's front door. The Royal Navy has torpedo bombers, the RAF has fighters, coastal radar is watching, and yet the escorts that matter aren't the ones throwing up flak from the decks. They're above the ships, turning the air into a locked gate. Because in this moment, the British aren't simply trying to stop a dash through the Channel. They're trying to solve a far more embarrassing problem: why their best frontline fighter, so recently the hero of 1940, has suddenly started losing head-to-head fights over France. Because in this moment, the British aren't simply trying to stop a dash through the Channel. They're trying to solve a far more embarrassing problem: why their best frontline fighter, so recently the hero of 1940, has suddenly started losing head-to-head fights over France. And the aircraft responsible isn't a sleek, liquid-cooled thoroughbred like a Messerschmitt. It's short, broad-shouldered, and radial-engined. Exactly the sort of machine that, by the conventional wisdom of the 1930s, shouldn't be winning at all. However, it is. And if you were a Spitfire Mk V pilot in late 1941, the first time you saw it really roll into firing position, you'd understand why the Luftwaffe nicknamed it after a bird that impales its prey on thorns. But we won't name it yet, because the real story isn't that it was Germany's best fighter. That's far too tidy. The real story is that it was, in many ways, a design that should have been doomed, and yet it delivered Germany one of its most tactically decisive single-engine fighters of the war. So what exactly was this butcher bird? By the mid-1930s, German fighter thinking had become dangerously narrow. The Messerschmitt Bf 109 was the Luftwaffe's rising star, fast, compact, and tuned like a racing engine. But it was also, to put it politely, a bit of a prima donna: tight undercarriage, tricky ground handling, and limited growth margin if the war demanded heavier armament, more fuel, or more rolls. Focke-Wulf, based in Bremen, saw the opening. The chief designer was Kurt Tank, German, stubborn, and unusually practical. While Willy Messerschmitt pursued minimum size and aerodynamic finesse, Tank leaned toward ruggedness, pilot survivability, and maintainability. It wasn't romantic, it was industrial, and that mattered. The requirement that shaped the aircraft was essentially this: produce a single-seat fighter that could complement the Bf 109, rather than replace it, something with greater firepower potential, better handling on rough airfields, and a layout that could accept future power increases without becoming a structural hostage. Tank's team made a choice that looked almost heretical to many European fighter designers of the period. They would center the machine around a radial engine. Radials had advantages: air cooling, battle damage tolerance, and often strong low-level power, but they had one major public relations problem: they were fat. A wide frontal area meant drag, and drag meant lost speed. On paper, a radial-engined fighter was already starting behind the line. To claw back the aerodynamic penalty, the Focke-Wulf solution was to build the aircraft like a compact weapon system rather than a slender airframe with an engine attached. The fuselage was short and deep. Systems were arranged for accessibility. And the landing gear, this matters later, was wide track, retracting outwards into the wings. That alone reduced takeoff and landing accidents, compared with narrow track contemporaries, a quiet but very real contributor to combat readiness. The prototype FW-190 V1 first flew on the 1st of June 1939, with Tank's team moving from concept to air in the final months before Europe detonated. But here's where doomed design begins to earn its title. Because the engine intended to make the aircraft great, the BMW 801 radial that would power most operational versions was itself a complicated beast. It wasn't just big, it was a tightly cowled, high-output twin-row radial with systems that, when pushed, produced heat like a political argument in a Berlin ministry office. And early on, that heat didn't politely exit the cowling. It stayed, it built up, and it caused reliability and cooling headaches that slowed confidence in the aircraft. So the FW-190 entered development with 2 simultaneous problems. 1, it had to prove a radial fighter could be fast enough. And 2, it had to prove its specific radial engine wouldn't cook itself into scrap. To their credit, the designers didn't pretend physics could be negotiated with. They refined cooling, airflow, adjusted cowling and fan arrangements, and treated the aircraft like a whole system: engine, airframe, armament, and pilot workload. And then, as production decisions finally hardened, the Luftwaffe faced another reality. This was not a hand-built thoroughbred like early Bf-109S. This was a fighter intended to be produced in large numbers, dispersed across factories, and adapted into variants: fighters, fighter bombers, ground attack aircraft, bomber destroyers. In other words, it was being designed not just to win dogfights, but to survive the war economy that would eventually surround it. With prototypes matured and initial production variants in motion, the real test would come not in a brochure but over the Channel, where the RAF had become used to meeting German fighters that behaved a certain way. However, the next German fighter would not play by those rules. Operational debut, the shock of 1941, the FW-190 entered service in 1941, and its arrival over northwestern Europe created a very specific kind of panic, the sort that only happens when experienced pilots can't explain what they've just lost to. Against the RAF Spitfire Mk V, the new German fighter was reported as faster and with a superior roll rate, meaning it could change direction and bring guns to bear with startling speed. The Spitfire could still outturn it in a sustained circle, but combat isn't an aerobatics display, it's a sequence of positioning problems under stress. And in those problems, roll rate is often king. This wasn't merely a bit better. Contemporary comparisons and later summaries repeatedly note meaningful speed advantages at various altitudes, enough that the German fighter could often choose when to engage and when to leave. What's remarkable is that this wasn't achieved by making the aircraft delicate. It was tough. The wide gear helped operational tempo from forward fields. The aircraft systems layout reduced certain maintenance burdens, and the pilot sat behind a solid, workmanlike instrument panel in a cockpit designed for combat rather than romance. But how did it feel in a fight? Imagine you're in a Spitfire Mk V and you spot a German fighter crossing your nose. You bank to follow. He doesn't tighten into a turn. He simply flicks, snaps into a roll, reverses, and drops his nose with a speed of response that makes your own aircraft feel briefly like it's thinking about the question. And then the guns speak. The captured example. The RAF gets answers. In 1942, the RAF received an intelligence gift. An FW-190A3, work number 313, ended up in British hands after its pilot mistakenly landed at RAF Pembrey. That aircraft became one of the first captured FW-190As evaluated in depth, helping the British understand what they were facing and, crucially, how to counter it. This is one of those moments where war turns on human error rather than industrial planning. Because once the RAF could test the aircraft, the myth could be replaced with data, and that data fed into tactics and urgency for improved Spitfire variants. A tactical triumph. The Channel Dash now returned to our cold open. Operation Cerberus, the Channel Dash, supported by the air component, often discussed alongside it. Operations that began on the 11th of February 1942. The capital ship's run relied heavily on air cover to blunt British attacks. It wasn't that the FW-190 alone won the Channel Dash wars, don't work like that, but its presence as a high-performance, hard-hitting fighter helped create an air environment in which British attacks were disrupted, delayed, or broken up. The aircraft's ability to accelerate, roll quickly, and hit hard mattered in exactly the kind of chaotic, low-level, time-compressed air fighting that covered a naval dash through constrained waters. Strengths revealed. Why the FW-190 was feared. As the war widened, the FW-190's strengths proved unusually broad. 1. Firepower growth margin. The aircraft could carry heavier armament than many contemporaries. This wasn't just bravado. More weight meant more strain, and the airframe could take it. 2. Ruggedness and operational practicality. Wide landing gear reduced attrition from accidents, an unglamorous but significant factor, especially as pilot training standards declined. 3. Roll response and handling as a gun platform. Even many non-technical summaries keep circling back to the same point. Roll rate. In combat, the ability to reposition your guns now is often more decisive than a slightly tighter sustained turn. 4. Versatility. Unlike aircraft that remained fighters in the purest sense, the FW-190 became a true workhorse across roles: fighter, fighter-bomber, ground attack, and later bomber-interceptor duties. Weaknesses discovered. The price of the design, and yet the same features that made it formidable made it vulnerable in other contexts. The radial engine gave strength and power, but also complexity and cooling sensitivity, especially as Germany's fuel quality declined and maintenance conditions worsened. And while the FW190 could dominate at certain altitudes and regimes, high-altitude performance, particularly for earlier radial engine variants, was not always where it needed to be, as the air war shifted toward bomber escort battles at height. This is where the doomed part of the story sharpens. The aircraft wasn't doomed because it was bad. It was doomed because the war changed faster than Germany could reliably keep its fighters optimized, supplied, and flown by well-trained pilots. Evolution, variance, and changing roles. As we discussed earlier, Tank's philosophy built in growth margin, and the FW190 used it ruthlessly. By 1944, the aircraft had become central to Germany's desperate attempts to blunt American daylight bombing. That meant facing tight formations of heavily armed bombers, targets that could absorb punishment, and escorts that were improving month by month. So the FW190 was adapted into bomber-destroyer configurations, including heavily armed variants, such as the FW190 A8/R2, associated with Sternbock bomber-destroyer operations. These aircraft traded agility for armor and punch, essentially turning the fighter into a short-range battering ram with guns. The logic was brutal, and so were the results. If you could close to very short range, concentrated cannon fire could shatter a bomber. But getting to that range meant flying through defensive fire and escort fighters. It required discipline, nerve, and often a willingness to accept losses that Germany could increasingly ill afford. Meanwhile, on other fronts, the FW190's ability to carry ordnance and take punishment made it valuable in ground attack roles, including service in specialized attack units on the Eastern Front, where its versatility could be exploited in a different, more tactical air environment. The long-nose answer, the Dora and late-war urgency. When altitude and speed at height became more critical, the Luftwaffe pursued the long-nose solution, fitting an inline engine installation that culminated in the FW190 D9, powered by the Junkers Jumo 213 family. The D9 entered service late in 1944, with multiple soaring initial operational introduction in that period, including participation by units such as JG2 and JG26 in late-war operations. This was the aircraft trying to do, in 1944 and 1945, what the original had done in 1941, restore a local advantage through performance. But the reality proved different, because by then, Germany's pilot training pipeline had been hollowed out, fuel shortages bit hard, and the Allies could replace losses at a scale the Luftwaffe simply couldn't match. Even a very good aircraft can't win an air war in an economy that is collapsing around it. Production scale. The numbers behind the legend. Despite the worsening strategic situation, the FW190 was built in enormous numbers. Multiple reputable museum and reference summaries converge on totals around 20,000 aircraft of all variants. And if you want a reminder of just how much metal that represents, the A series alone is often cited with 5-figure totals in aggregate. So yes, this aircraft mattered not as a rare wonder weapon, but as a mass-produced instrument of tactical effect. And that brings us to the central contradiction of the title. The FW190 as a concept delivered tactical triumph after tactical triumph, shocks over the Channel front, effective multi-role service, and a brutal late-war punch against bombers. Yet strategically, it was part of a system that could not sustain the war it was fighting. It was, in a sense, the right aircraft serving the wrong trajectory. By May 1945, the European war was over. And the FW190 story ended not with a ceremonial retirement, but with surrender, captured airframes, and post-war evaluations. Its legacy is easier to see when you look at what survived and what had to be reconstructed. Today, surviving examples are scattered across museums, with major institutions holding important variants. The RAF Museum's collection notes the type's broad production and wartime service, grounding the legend in industrial reality, and remarkably, only one original FW190 is commonly cited as airworthy in modern times. The Flying Heritage and Combat Armor Museum's FW190 A5, often referenced as the sole flying original example. There are also persistent misconceptions worth correcting. One is that the FW190 was invincible in 1941-42. It wasn't. It had weaknesses, particularly when drawn into prolonged turning fights where the Spitfire could exploit a tighter sustained turn, and in regimes where altitude performance mattered more than low-level punch. The FW190's advantage was not magical, it was situational, tactical, and very real. Another myth is that the aircraft's success was purely about raw speed. Speed helped, but the way it maneuvered, especially in roll, and the way it could be adapted into variants mattered just as much. It wasn't a single trick, it was a design philosophy, and that's where Kurt Tank's fingerprints are most obvious. The FW-190's broader lineage and the way German late-war developments carried his name, seen, for example, in the TAR-152, developed from the FW-190 line, shows how foundational the airframe concept became. So was it a doomed design? Not in the engineering sense. The airframe was strong, adaptable, and in its best context, superb. But strategically, yes, it was doomed, because no aircraft can outfly a collapsing logistics system, a shrinking pilot training program, and an enemy who is learning, adapting, and mass-producing faster than you are. And yet, if you strip away the post-war mythology and look at the FW-190 as its pilots likely saw it, an honest, hard-hitting machine that could give you options in a fight, then tactical triumph is not an exaggeration. It is perhaps the fairest description. A butcher bird built for practical killing, flown in an increasingly impractical war,